Okay, physicists, here's number 9. Almost there. Number 9 says a football is kicked at 37 degrees to the horizontal at 20 meters per second from the player's hand at 1 meter from the ground. Take each of those one step at a time here. But ultimately, we want to know how far the football traveled before hitting the ground. Let me label this as number 9. Way off on the edge of your screen there, sorry about that, and then start making my variable lists. So I know that A equals 0 meters per second squared in the x direction. And last I checked, football, both American and otherwise, was an earthling sport, so I'm going to assume I'm on Earth. Problem doesn't tell me otherwise. It's a pretty fair assumption to make. I do, however, need to break down my velocity, my 20 meters per second, which was launched at an angle of 37 degrees, into its two components. So my y component is going to be 20 times the sine of 37 degrees. Sorry that went off your screen, but that will give you 12.04 meters per second. And my x velocity component is 20 times the cosine of 37 degrees, which is going to give me 15.97 meters per second in x. So let me put those values in. And then look back at my problem, because there is one more thing that I know. That's that the player's hand, so where the ball left, was at 1 meter. Now remember, for delta y, we do final minus initial. So it ended on the ground, which is a final position of 0, minus its initial position of 1 meter. So my delta y is going to be negative 1 meters. So this is essentially the same problem that I've solved the last couple of times. My delta y value is just a little bit different. And that's going to be important when you get to the quadratic. So let's go ahead and fill in to our equation. Delta y equals VIT plus 1/2 AT squared. Delta y is negative 1. VIY is 12.04 times t plus 1/2 times negative 9.8 times t squared. And this is where you have to be careful. Again, this is a quadratic equation to solve, but if you're solving the negative b plus or minus square root of b squared minus 4ac all over 2a equation, you have to move this 1 first. You would add 1 to both sides, and that would become your c value. Graphing it, you don't necessarily have to do that depending on how you graph it, but just be very careful of this negative 1. You'll get a slightly different answer if you have 0, and that answer is not as right. So be careful of that negative 1. Regardless, when I solve this, I get a time of 2.53 seconds. And to figure out how far, I'm going to plug into delta x equals vx times t, or 15.97 times 2.53, which gives me rounded 40.4 meters. And now I just have one more problem left to do.